Okay, this video tutorial looks at cubic polynomials, and more specifically, we're going to focus our understanding on how to solve cubic polynomials. So basically, how do we solve a cubic? There are a few different methods to solve a cubic polynomial, but first we need to know how to factorize them. And there are a few methods that we're going to look at in this video tutorial. The first one being the null factor theorem. The second one being taking out common factors, the third one being grouping, and the last one being using the factor theorem to find a linear factor, and then obviously then factorizing and solving the remaining quadratic. So using the null factor theorem, basically when a cubic polynomial is written with brackets and equals 0, we can use the null factor theorem to find its factors. The null factor theorem basically states that if an equation equals 0, then everything that is multiplied together, all right, at least one of those things must equal 0. So in this particular case, we have x take 1 equals 0, x take 2 equals 0, and x plus 3 equals 0. Now, we don't know which one of those equals 0. They may all equal 0, but at least one has to equal 0. And we just simply solve these equations separately. So here we have x equals 1, x equals 2, and x equals minus 3. So solving a cubic polynomial with a null factor would give us these answers here. Sometimes we can take out common factors. So we remove the common factor from the cubic to make it a quadratic, which makes it a lot easier to factorize. We can just use the product and sum method to solve the remaining quadratic of the cubic polynomial. So as an example, if I wanted to remove a common factor, I'm going to remove x as my common factor. That's going to leave me with x squared plus 5x plus 6, and that all equals 0. I've now taken the x out. I know that x could potentially equal 0. Now what I'm going to do is I'm going to factorize the quadratic within the brackets to get two sets of brackets using the product and sum. Basically, product and sum is I need two numbers that when add together give me 5, but when multiply together give me 6. The answers are 2 and 3. So this becomes x outside of x plus 2, x plus 3, all equals 0. We know already that x equals 0, so we've got x equals 0, and that's coming from the x that's outside the brackets. We've then got x plus 2 has to equal 0, and x plus 3 also has to equal 0. So therefore we can say x equals minus 2 or x equals minus 3. Therefore, our solutions are x equals 0, negative 2, or minus 3. Now, depending on the cubic polynomial that we're actually looking at, we may have an opportunity to use the method of grouping to help solve a cubic polynomial. So what this does is basically allows us to find a common factor, and it's usually a linear factor within our cubic polynomial, and then we basically rewrite the polynomial as one linear expression multiplied by one quadratic expression. An example of this is I could rewrite this quadratic as x squared. So I've taken x squared out as a common factor at the start, take 2, and then what I've done is I've taken 8 out as a common factor in the second half of our quadratic, our cubic, and that's going to equal 0. So you can see here that I've actually now got the same common factor. I can now take that out the front, x take 2, and whatever's left over goes in my second bracket, so that my first bracket is my linear expression, my second bracket is my quadratic expression. And I now simply just solve these. So I've got x take 2 equals 0, or x squared take 8 equals 0. Therefore, x is going to equal 2, or x squared is going to equal 8, and x is going to be the square root of 8. So therefore, my solutions would be x equals 2, or plus or minus the square root of 8. Okay, so sometimes we can use the factor theorem to find a linear factor. And basically, this will allow us to basically have a quadratic remaining and to find a linear expression that we can then divide into. And then basically we're going to try and factorize the remaining quadratic using the product and sum to be able to factorize our original cubic equation, and then we'll be able to solve it. So first thing I'm going to do is I'm going to just through inspection basically trying to find a number that I can replace with x to get me to equal 0. So let's say I've got my p of x, so my function of x cubed take 4x squared take 11x plus 30. I need that to equal to 0. I'm going to try p of 2 just through inspection. That gives me 8 take 16 take 22 plus 30. This is going to, when I add all that together, is going to give me an answer of 0. So therefore I can say that x take 2 is actually a factor. All right. Now what I'm going to do is I'm going to do my division. I've got x take 2 all into x cubed take 4x squared take 11x plus 30. All right. What I'm going to do is I'm going to find out that I need to multiply my linear expression here by x squared. All right. That's then going to allow me to have x squared underneath take 2x. Whoops, that's meant to be a cubed, by the way. And I'm going to start my long division process here. All right, this is going to give me 0, and this is going to give me negative 2x squared. I'm then going to bring this down and have negative 11x. I now need to figure out that I'm going to multiply my original divider by negative 2x, which is then going to allow me to take 2x squared plus 4x. Taking a take as an add, that gives me 0, and that gives me negative 15x. If I multiply this by negative 15, and I bring this 30 down, that allows me to therefore end up with a remainder of 0. So I can see that my remaining quadratic is going to be x squared take 2x take 15. Now, basically, I've now got my original cubic, which is over here, in the form of x take 2 and x squared take 2x take 15. All I need to do now is to factorize the second part of my cubic, which is the quadratic, using the product and sum. If I do that, I'm going to end up with x take 2 at the front, x take 5, x plus 3. Therefore, I can say if this all equals 0, I can say that x must be either 2, 5, or minus 3 using my null factor. Okay, so here are some practice questions I would like you to have a go at. Please feel free to pause the video and recap some of the things we've covered. Once you think you've got the answers correct, continue the video and we'll see how you went. Okay, so in these first couple, we're looking at the null factor for our first equation. So we've got x plus 1 equals 0, x take 2 equals 0, or x plus 4 equals 0. Therefore, we can say that x is equal to negative 1, positive 2, or negative 4. In our second question here, we're basically taking out a common factor. So if we take out x as a common factor, it leaves us with x squared take 7x plus 12 equals 0. We can now use the product and sum method to solve or to factorize our quadratic. We've got x take 3, x take 4 equals 0. So therefore, x either equals 0, 3, or 4. Now these ones were a little bit trickier. In our C question, we're looking at grouping. So here we're going to take out x squared as a common factor and be left with x take a. We're then going to take negative 11 out as a common factor and end up with x take a, all equaling 0. So therefore we've got x take a in one bracket, x squared take 11 in the other bracket, that'll equal 0. So therefore x either equals a or x will equal plus or minus the square root of 11. Okay. And in our last example, we're essentially trying to find a linear expression that's a factor. So we're trying to find a factor just by inspection. Once you've inspected enough, hopefully you found that p of 1, okay, equaled 1, take 2, plus 2, and you would have found out that that was 0. So therefore we know that x take 1 is a factor. We then simply need to divide our x take 1 into our original cubic, which was x cubed take x squared take 2x plus 2. If you've worked that out all correctly, let's just quickly go through that. We have x cubed take x squared, so this becomes that, which then gives us x squared up here. We actually get nothing here, so we need to bring this down, and we end up with negative 2x plus 2, and then this becomes negative 2x take 2, which then gives us a remainder of minus 2, or no remainder, sorry I should say, but a quadratic up here, and we end up with x squared take 2. So therefore we end up with x equaling 1 or x equaling plus or minus the square root of 2. And here we work that out using our null factor.